We've been talking about compound interest using this formula A equals P times the quantity 1 plus I to the n. Remember, P is what we start with, I is the interest rate per period, and n is the number of times we compound. So we have four variables here, A, P, I, and n. And in this form, we usually solve for A, for the future value. But if A, I, and n are known, we could also solve for P. And in that case, we'd think of this as the present value, or the original amount. Suppose you want to have $20,000 in 18 years for your child's education. How much would you need to deposit today at 8% compounded monthly to end up with that? So we want to know, what do we need to have at present so that when we compound it into the future, we end up with a future value of 20,000. So we're going to go ahead and start with our compound interest formula. A equals P times the quantity 1 plus I raised to the n. And now let's start putting our values in. So the A for this problem is 20,000. That's what we want to end up in the future. We have an 8% interest rate, and we're going to do this 12 times through the year. We're going to be compounding 12 times 18 times over that period. So what we need to know is P, the present value, so we're going to solve for it. So we'll go ahead and divide by this big factor here, the 1 plus 0.08 divided by 12 raised to the 12 times 18. So there I am, solved for P. Probably the hardest part of this problem is going to be to go ahead and put this into your calculator so you can figure it out. You'll need to make sure that you use parentheses very carefully. So 20,000 divided by all this stuff on the bottom. So when you put it into your calculator, you'll need a second set of parentheses. When you do that, you should end up with $4,761.25. So if I deposit that today, I leave it in the bank for 18 years at 8% compounded monthly, I'll end up with 20,000. Be careful here. I have rounded to the nearest penny, so if you actually do this, you might come out with slightly more or slightly less, depending on how you did your rounding. If you need to end up with 20,000, you should probably round up. We could come up with a formula for this, which is the present value P is equal to A divided by the quantity 1 plus I raised to the n. And we could use this as a formula, but I kind of prefer just to use our compound interest formula, put the numbers in, and if I have to solve for P, I go ahead and solve for it. That means I just have one less thing that I have to memorize in this class. Let's go ahead and do a problem. This one says, how long would it take for you to double your initial investment at an interest rate of 12% compounded annually? I'm kind of using that 12% here because, the stock market, some years it does better, some years it does worse, but 12% is not it's a pretty good few years. So if we had this average out to 12% each year, we could ask ourselves exactly this question: how long does it take to double? Notice that I didn't give you an initial amount. That's because if you start with P and you want to double it, you're going to end up with 2P. I can say start with P, end up with 2P, so that's going to be my future value. So I'll go ahead and put in my 12%. It said compounded annually, so that means 1 times a year. And what I need to find out from this is n, how many years am I going to have to do this for? Now this might bother you, the fact that we have a variable here that we need to solve for, but also a p in this, but I can divide both sides by p and end up with 2 equals 1.12 to the n. And what this tells me is the initial amount is irrelevant. How long it takes to double your money has nothing to do with what the amount is that you start with. But I do have a fairly complicated looking equation here that I need to solve for n. So the way to do this is to go ahead and take the logarithm of both sides. So I have log of 2 equals the log of 1.12 raised to the n. And if you remember from college algebra, when you have powers inside of logarithms, those can come down in front. So we have log 2 equals n times log of 1.12. Now that this n is in front, we can go ahead and divide both sides by log of 1.12. So we get log 2 divided by log of 1.12 equals n. If I put that into my calculator, I get that n is 6.1. So I'm going to have to compound 6.1 times, and since I'm compounding annually, that means 6.1 years. So in 6.1 years, I'm going to double my money if I can average a return of 12% each year.